Hello and welcome to this video tutorial on how to verify whether a function is an inverse of another function. Before we look at our example problem, I would like to answer a few questions that you may have. First, you are probably wondering what inverse functions are. In simplistic terms, inverse functions are functions that undo another function. More formally, when you compose a function such as f of x with its inverse f inverse of x, or vice versa, it will evaluate and then simplify to x. Second, you probably want to know how to determine whether two functions are inverses of each other. In order to do so, simply compose the two functions both ways, f composed with g and g composed with f. In doing so, ensure that both compositions evaluate and then simplify to x. If both do not simplify to x, then your two functions are not inverses of each other. So now, let's discuss our example problem, which is verify that f of x equals the square root of 9 minus 3x and g of x equals 9 minus x squared all over 3 with the restriction that x is greater than or equal to 0 are inverses by using composition. The process I would use to solve this problem is first to check whether or not the first composition, f composed with g, evaluates to x. The second thing I would do is check whether or not g composed with f also evaluates to x. And third, I would determine if the given functions are inverses of each other. So for the first step, we need to determine if f composed with g simplifies to x. The first thing we have to do is substitute 9 minus x squared all over 3 for x in f of x. In doing so, our result will be the square root of 9 minus 3 times 9 minus x squared all over 3. Second, we need to fully simplify the entire expression. So the first thing we're going to do is cancel the 3's, because we can easily see that that factor of 3 that's on the outside cancels because of the factor of 3 in the denominator of the fraction. The second thing we need to do is distribute the negative. In doing so, we'll get the square root of 9 minus 9 plus x squared. Now, we can easily see that those two 9's cancel and we're left with just the square root of x squared. So, our result will be plus or minus x. However, remember that we have that restriction that says that x needs to be a positive number. So, we have to actually discard the negative x because it doesn't fit with that restriction, which means that our final result is just x. For the second step, we need to determine if g composed with f is going to get the same result. So, the first thing we need to do is substitute the square root of 9 minus 3x for x in g of x. In doing so, we'll get 9 minus the square root of 9 minus 3x squared all over 3. Second, we need to fully simplify this expression. So the first thing we're going to do is undo that square root, because that whole square root is what is squared. Once we do this, we'll distribute the negative and then combine like terms, getting us a final answer, which we'll have to divide, of 3x all over 3. Once we divide that by 3, we'll see that our actual final answer is x. So now, we need to determine if f of x and g of x are inverses. First, ensure that both the compositions f composed with g and g composed with f simplified to x. Since they did, due to the restriction of x greater than or equal to 0, these two functions are inverses of each other. Thank you for watching, and I hope you enjoyed this video.